Hey everyone, for my SPCOM course project, I chose to do aquifer and groundwater utilization. We're going to be taking a look into sustainable water management, as well as the drawbacks and implications of this resource. So let's talk about water management for a second. Extreme weather events are becoming more and more common, making water contaminated, scarce, or otherwise unavailable. These threaten sustainability, development, biodiversity, and access to water and sanitation. All of these are very bad for people and the environment. Some examples of issues concerning water management include extreme storms, water contamination, and droughts. Unfortunately, all of these factors will only increase in probability and magnitude with climate change. The main solution to these problems that I'll be covering in this presentation are aquifers. Aquifers are subterranean bodies of underground water. They can be found in large caverns or small spaces in subterranean rock. So some of the predominant uses of aquifers include water consumption for both personal and industrial uses, sustainable energy supply, and managed aquifer recharge. We'll get into more detail on those later. So consumption of aquifers can range anywhere from personal to industrial uses. Personal use of aquifers makes up a significant portion of freshwater consumption. Rural communities and indigenous reserves often source the majority of their water from aquifers. Large industries also source a significant portion of their water from aquifers. This water is used for needs such as mining and steel manufacturing, plastic and chemical production, and also agricultural uses. Something that I found particularly interesting while conducting research for this project was that up to 40% of the world's freshwater supply came from aquifers. Aquifers may also be used as a source of heat. Aquifer thermal storage systems are a relatively new technology that makes use of subterranean aquifers and their ability to insulate thermal energy. As a result, aquifer thermal storage systems have shown potential as an energy-efficient commercial and residential heating and cooling system. Aquifer thermal energy storage systems, or ATES for short, work by storing water in an open aquifer nearby to a building. This water is then pumped into a heating or cooling chamber and then pumped throughout the building. This allows for steady temperature control for the residents. After the water has done its job, it's pumped out of the building and back into an aquifer. The water is then able to retain more of its thermal energy. The last main form of aquifer usage that I'll be discussing in this video is managed aquifer recharge, or MAR for short. MAR consists of the managed replenishment of a depleted aquifer. Water stored in an aquifer can be used when surface water becomes contaminated, scarce, or otherwise unavailable. Agricultural industries already make use of MAR technology to sustain crops during drought seasons. Replenished aquifers can strengthen wetland habitats. Groundwater is often connected to surface water as part of a larger hydrology system, and groundwater discharges into surface water through natural springs. Small amounts of municipal stormwater can be treated before storage in aquifers. Waterloo's MAR system is managed through the Mannheim Water Treatment Plant. They call the process Aquifer Storage and Recovery, or ASR. Its goal is to ensure the availability of sustainable water supply for the city of Waterloo. Although aquifers have plenty of practical applications, there are still plenty of areas of development and limitations to current aquifer technology. For example, as previously mentioned, only small amounts of stormwater can be processed using managed aquifer recharge systems. The biggest restriction is water quality concerns. Before we can pump water down into an aquifer, we have to make sure that the water being pumped down won't negatively impact the quality and geochemistry of the aquifer. This is particularly important because once an aquifer is contaminated, it can take many years to remediate. This means that the bottleneck for using this method to handle stormwater would be how fast we can treat the water at a treatment facility. One current field in development to deal with this situation is phytoremediation. Phytoremediation is a fairly new method for treating water. However, it's already being used in urban development for projects such as parking lots. Phytoremediation is able to treat stormwater so it can safely be pumped into aquifers without contaminating all the groundwater. Just like any technology, aquifers are continuing to develop and become better as time progresses. The future of aquifer technology will shift more than likely towards computer-generated models and AI to help map groundwater. Pipelining water from areas with flooding issues to areas that have issues with droughts for MAR storage will also become more common. To summarize, aquifers can be used for sustainable energy, water storage, and industrial uses. So what are the implications? As water use management in general becomes more and more important, any topic that revolves around determining how much water we can sustainably take from a given source will become more important. As I hope you've learned from now, aquifers are a versatile technology with many applications. Thanks for watching my presentation, and I hope you've learned something.